I, Dr. Nidhi Sharma, Assistant Professor Chemistry, ARSSMS, Institute of Information Technology, Pune, welcome you all in today's lecture. My today's topic is engineering materials. Now, engineering material is again divided into two parts, the specialty polymers and nanomaterials. So this engineering material is divided in two parts. So specialty polymer weightage is 9 marks, nanomaterial marks weightage is 9 marks. Now first of all I am going to discuss in today's lecture about the polymer. So first, that what is polymer? So before knowing the polymer, we should know the monomer. Monomer is the simple chemical substance of very low molecular weight which can be converted into polymer, and the molecule of monomer which has at least two easily reacting position can work as a monomer to form the polymer. So this is a required condition for the formation of polymerization, that the monomer should have at least two easily reacting positions. Now what is monomer? A compound formed by many small simple chemical units to form a very long chain compound with very high molecular weight is called polymer. As you can see, suppose if we have taken the monomer M, so it is going to form polymer. Here we have given the example, like here suppose I have taken ethene molecule, so with the help of polymerization reaction it is going to form polyethene. So that's how the polymer formation takes place. Now next is, polymers are very giant molecule with very high molecular weight, that's why it is called macromolecule. So there are so many uses of polymer. Synthetic polymer finds their uses as a substitute for different materials like nowadays the metals, woods, cotton, wool, gums, glass, ceramics, all can be made up from polymers. Polymers are used in automobile engineering, mechanical engineering, electrical engineering, civil engineering, medical and agricultural, and there are so many other fields in which the polymers are used. So first we will focus the classification of polymer. The polymer is basically of two kinds, natural polymer, synthetic. Natural polymer means the polymer which you are getting directly from the nature. For example, wood, cotton, wool, leather, cellulose, etc. Synthetic means the polymer which is made up of chemicals, example polypropylene, polystyrene, etc. These are the examples which are made up of chemicals only. So next very important topic is engineering thermoplastic. Now what is engineering thermoplastic? It is actually, the engineering thermoplastics are group of materials obtained from very high polymer resins which provide one or more outstanding properties when compared with the commodity thermoplastic. Means when the common utility thermoplastics like polyethylene, polystyrene, when these all are compared with engineering thermoplastics, so it was found that engineering thermoplastics are having more improved properties, outstanding properties. So what are the actually advantage or improved properties of engineering thermoplastics? It is having a high thermal stability, high tensile strength, high impact strength, high chemical resistance, high flexibility, high mechanical strength, very lightweight, easily, readily moldable into complicated shape. So these actually, this lightweight, readily moldable, these two properties are very important properties which has made the use of engineering thermoplastic very important. So we can understand like these are the required properties for any engineering work thermoplastic, but these are the properties which are very important for any type of polymer. So these advantages gives the scope of this engineering thermoplastic in automotives, electrical, electronics, computer components, satellite, robot, aerospace, and the examples of engineering thermoplastic are polycarbonate, polysulfones, Teflon, PPV, etc. These are the examples. So basically we are focusing on engineering thermoplastic. So here I am taking the one example of engineering thermoplastic, which is polycarbonate. In short, it is also known as PC. Another name is Laxson Merlin. These are the name of the polycarbonate only. Now polycarbonate is what? Polycarbonates are thermoplastic polyester having functional group linked together carbonate group chain molecules. As you can see here the carbonate group chain molecules, so that's why it is called polycarbonate. This polycarbonate is made up of, this is diphenyl carbonate, this is bisphenol A. So when bisphenol A reacts with diphenyl carbonate, it undergoes polymerization and it results in the formation of polycarbonate. Now, what is the important property which this polycarbonate possesses? It is having very high impact strength and high tensile strength. Its melting point is 265 degrees centigrade and heat resistance is up to 140 degrees centigrade. And due to the very high having very high tensile strength, transparent refractive index, it is 1.58. This is very important property. It is highly transparent plastic and transmittance is 88%. This property is very important. That's why it found the use in optical articles also. Resistance to water and many organic compounds, and it dissolves in organic solvents and alkali. So it has very good heat resistance 140 degrees centigrade. It has low combustibility, it has high melting point and limited chemical and scratch resistance, no resistance to UV. So polycarbonate have limited chemical and scratch resistance, that already we explained, so that is very important, and no resistance to the UV. So now the application of the polycarbonate. First, it is used as a security component. So as a security component means polycarbonates can be laminated to make bulletproof glasses. So this is a major application. Then second is electrical and electronic components. So being a electric insulator having heat resistance and flame retardant property, it is used in various products associated with the electrical and telecommunication hardware. So that it can be used for the electrical insulators, it can be used for electronics, telecommunication hardware, industrial plugs, socket, switches, cover of cell phones, laptop, pagers, etc. are made up of polycarbonate. Then third, it can be used for the data storage. Major application of polycarbonate is the production of CD, DVD, Blu-ray discs. These discs are prepared by injecting molding of polycarbonate. Then fourth is the use of optical application. As I have told in the beginning, the property is 88% transmittance. It is transparent in nature. So due to the high optical clarity, it is used for making sunglasses, swimming and scuba goggles, safety goggles, visors in the helmet, automotive headlamp lenses. It is also used for the windscreen for motorcycles, golf carts, small planes and helicopters. It is also used for the electronic display screen used in mobile and portable devices of some LCD screens. And polycarbonate can be used for making ultralight eyeglass lenses. This thin PC lenses, polycarbonate lenses can correct poor vision and need not to be thick as a glass lens. So nowadays polycarbonate lenses are used. Then after that it can be used as a construction material. Polycarbonate have high light transmittance, high impact strength and tensile strength. So they are used as a substitute for window glasses. They are used in the dome lights, flat or curved glazing and sound walls. It can be used for this purpose. Then some other applications also. The polycarbonates are used for housing for machinery apparatus such as hair dryer body, camera, binocular bodies. Polycarbonate are also used for molded domestic wares like food containers, cooking utensils, cover, blender jars, drinking bottle, glasses, toys, etc. So these all are the uses of polycarbonate. So thank you all. That's all for today's lecture.